All right, guys, now we're going to put the trig functions that we learned, sine, cosine, and tangent, to use. What we did previously was very arbitrary. There's random triangles, and we're trying to do the basic skills, but these next problems kind of let you know where trig is actually used outside the classroom. So these notes are on the Google Classroom, and there's an assignment that goes along with these notes I'd like you to do. But hopefully this video can kind of help explain the notes a little bit. We're just going to do angle of elevation. Next class we'll do angle of depression, but for today we're just going to concentrate on angle of elevation. And the first thing we need whenever we have angle of elevation is we need to have a right triangle. And then we need to be given either two sides or a side at an angle. And finally, what we need to solve for is what is being asked for, which you'll see in a little bit. First, the angle of elevation is always on the base of the right triangle. So the angle of elevation is always here or here. It's never up top. So think of it as we're on the ground looking straight up across, and then what's our angle looking upward? We're on the ground looking straight across, and then what's our angle looking upward? Once again, it's never on top. And then give it a second for this to clear up. Very good. And then finally, we must read and understand the problem to solve it. Once we understand the problem, we draw the right triangle, label it, and solve it. So the picture is of the utmost importance. And you don't need to be Vincent van Gogh here, or Leonardo, or Donatello, or Michelangelo, or Raphael. There's all the 4 Teenage Mutant Ninja Turtles. For those of you who know that reference, awesome. For those of you who don't worry about it. But this is literally what we're doing. If we have a flagpole that's 40 feet tall, well, if I drew a right triangle, this would represent the flagpole, the line going straight up and down. The shadow would obviously be the line on the ground. Okay, so we have a 40-foot tall pole and a 65-foot long shadow, and I want the angle of elevation. Well, as we learned previously in a right triangle, if I want this angle and I'm given the opposite and the adjacent side, I want to use tangent. And when I'm trying to find an angle, we always use -1. The inverse tangent button. If we were trying to find sine, the measure of a side, we'd just use tangent. But here we're trying to find the measure of an angle. So I have the -1, which means I'm going to use my second function for my tangent. So the tangent to that theta is opposite over adjacent, 40 over 65. And inverse of 40 divided by 65 using tangent is 31.61, which is our angle of elevation. Now we could look for something else. Sometimes we're looking for the height of the pole. So in this problem, they tell you the angle of elevation from the edge of a shadow to the top of a flagpole is 28 degrees. So they give you the angle of elevation and they tell you the length of the shadow. And in this case, we're trying to find the pole. So in this case, we're trying to find a side. So therefore, the tangent of 28 is equal to x over 30. We set that equation up, multiply both sides by 30, and we get 15.95. Here, if the angle of elevation is given and the height of the flagpole is given, but we're looking for the length of that shadow, the shadow is still down here, it's represented by x, and my flagpole is 35 degrees. You notice these are not great triangles by any stretch, but they do get the job done. And my angle of elevation, once again, is always in the bottom, it's 52. Whoops, sorry about that, it's 52. And now we set up tangent of 52 equals 35 over x. We multiply x on both sides, we divide by the tangent of 52, and 35 divided by the tangent of 52 is 27.34. Now we're not always going to use tangent. In this case, we're actually going to use sine. Take a look at this ramp. It has an angle of elevation of 17 degrees. Once again, the angle of elevation always in the bottom. And think about a ramp that can reach a height of 4 feet. Height is always straight up and down. This would be the base of the ramp, which we don't know. And we're looking for the length of the ramp. Where's the length of the ramp? It's the hypotenuse. It's the diagonal line here. So in this case, we need to read, understand what they're saying, and evaluate it. So we don't just automatically use tangent. In this case, we're going to be using sine, because the sine of 17 equals opposite over hypotenuse. And from there, we're just executing those trig functions. We multiply both sides by x and divide by the sine of 17, and we get 13.68. And that's why it's so important that you were able to understand the trig functions from the last two questions. Because without being able to do that, you can't apply those concepts and solve real-world problems. If we understand those concepts, these real-world problems become much easier. And these types of problems are actually very valuable outside the classroom. They're used all the time. All right, good luck with this.